All right, so we have Dave, and he's explaining why we have all this stuff. Because there's a lot of stuff going on here, and I don't know why. So Dave can explain it.
Well, reason for a closed loop wind tunnel is so that you can inject gas into it. So this one has the ability to inject any gas. So we'll put methane, hydrogen, argon, helium, whatever. We'll fill it up, goes through the regulator, we'll fill the entire system, and have that gas flowing in the entire system. And here's like a methane sensor that'll tell you what the concentration of methane, oxygen, other components. So we have another sensor that can tell you what the gas composition is. But nonetheless, once it's closed and there's no leaks, it's flowing gas. That gas that you put into it, we now characterize this flow meter or this flow meter or whatever flow meter with that gas with this closed loop system.
So I just want to back up here, and this lets us know exactly how much flow is flowing through the system, and then we can use that to calibrate. Is that
right.
Is that accurate? So
yeah.
This is basically a really, really good calibration system that we can use to find and subtract out any of the errors in the flow meter.
And I would say this is a method of characterizing a flow measuring instrument. So it characterizes and it speaks in its native tongue, which we've made it standard cubic feet per minute, that can be converted to any unit at any reference temperature and any reference pressure, and then take that characterization, program it inside of any device, this device or this device or the other one, wherever that one went.
And by characterization, we mean essentially mapping a output of the sensor to a flow rate.
Yeah.
So we're characterizing it by saying 0.3 volts equals 3,000 gallons per minute, and 0.1 volt equals this many gallons per minute.
Yeah, and that volts would be something for here, but this guy speaks volts, let's say. This guy speaks frequency, because it's fundamentally a time domain machine. And it's not a pretty square wave. We gotta clean it up to turn it to a pretty square wave. And this one isn't a pretty analog signal. It has all kinds of sensitivities to all kinds of things that we go and do transfer functions inside the micro. So this one's not this one's a little more complex, where we have to make it, if you will, by transformations inside the electronics to indicate the flow in the customer's units that they want.
And just one question, when you say time domain, I remember that anything that has an output that's frequency is in the time domain, is that right? And if something has an output that's in volts, that's the amplitude domain?
I don't know what domain it's called.
Doesn't matter, it's just...
Yeah.
But by time domain, all we mean is that we have an output that's a frequency, and we're mapping a frequency to a flow rate.
Yeah, time domain is pretty nice because it's simple to trace it back to something, because crystal oscillators are cheap. HP reference standards are cheap, relatively speaking. Boy, but a flow meter, this is a pain in the butt to make. This is not an easy thing to do. And not many people make these things full-blown like this, because it's a pain. It requires a knowledge of being a mechanic, if you will, and electronics and programming. You have to tie all those together. And the reason most of them don't work well is whoever's working on it, something gets missing. Something's missed. The person who's a mechanical engineer can't explain to the electrical engineer what is needed, because they're speaking different languages, and they really have not a whole lot of interest to satisfy each other. They're usually kind of a bit at loggerheads, like chiropractors don't like doctors. They should be friends, but they aren't. Therefore, things don't work too well.
Mechanical engineers, like, if you software guys could solve all the problems, then come on, it would be fine. And the software guys are like, you mechanical guys, how come you're not giving me good data?
You dummy, yeah, you did it wrong.
Yeah, you gotta get your act together. And at the end of the day, nobody's fully committed at characterizing the device properly and getting
Yeah.
rid of the errors.
And Elon Musk teaches us that there's a way to do that because he's coordinated things. He's made that electric car. So this one is working only because I have, you know, an interest in all three of the disciplines because it must work. So who could make it work? Yourself can make it work. So don't say I can't do it. Figure it out and do it.